it says, if x is between -1 and 1, that's the domain of arcsine. And if y is between -π12 and π12, that's the range for arcsine. If that's true, then when you take the sine of arcsine of some value, they say you're going to get the same answer. And that's just the definition of inverses, right? Like if you take the square root of something squared, do you agree that those kind of undo each other? If you take the cube root of something cubed, it undoes each other. If you multiply and then divide by the same number, those are all inverse operations. So does it make sense if you take the sine and then the inverse sign that it would undo each other and you would just get x back? That's all this is saying. But the big part is this has to be true. If that's not true, then you can't necessarily just cancel them out. And we're going to look at one in a minute, and I'll show you what I mean by that. So there's this for cosine and tangent, and so I'm going to show you these. If you want to write them, like, feel free to write them down. If you don't want to write them down, I'm okay with that too. Because all these are really saying is that when you take the cosine times its inverse, or the inverse of the cosine, that they just cancel each other out and you get y back. Just like when we did log stuff, I know it's been a while, but remember when you took like ln of e to the x, and ln and e are inverses, so you just got back x. That's because they're inverses. Like, that's the definition of inverses. They undo each other. So I'll show you these, and then we'll do some problems. And notice all these x's and y things, those are just the domain and ranges that we wrote out yesterday for all of our inverse traits. Remember what that little fancy e means down there? We just say if x is an element of the real number system, or it just means that x is a real number. Because remember the domain of tangent was all numbers. I've shown it before. People just always ignore it. And then we always write this above it. X is a real number. And that's usually what we write through this, but they don't want to look at the weird key. You blocked it out. You're probably too busy typing on the calculator. Don't say that about your calculator. You said yesterday. I just told them they should go home and watch the video because I just yelled at you like every time. My college algebra students informed me that if you turn on the, what is it on the YouTube, the captioning or whatever, on my videos, I say very weird things because it doesn't ever capture what I'm actually saying. And so it's very funny to watch my videos. You turn on the captioning thing on YouTube because I say weird things. And I said so much for actually learning, like watching the video and learning, and you're just reading the caption. But I haven't done anything else. But Scott finds it hilarious. Okay, can I go? Time to go. Still waiting. This is the most writing you have to do. After this, it's just problems.
Sounds like it picks up your voice. Like usually I have to turn up the volume all on YouTube.
I know, yeah. I know. I should. That's why I stand over here and always step on these cords and mess it up. Is because I try to stand here so that it works better, but I forget sometimes and get way over there. And that's why when I leave a recording and there's a sub, like my voice goes up and down a lot. But when there's a sub and I plan for it to be a recording, I pull the podium over here and I put the microphone right on the podium. But then every time I turn and talk to the board, then you can't hear me. So I had a little cool Bluetooth little headset thing that I wore for a while, but it made this awful buzzing noise when you listen to the recording, so I found it not to be that great. So someone should look into that and find me a good one to buy. Then I can be super cool and just wear this little headset all the time. Look like I work in the drive-thru. So here's the thing about those properties. They only work if you're in the specified interval. If you're not sure if you're in the specified interval, you can just do the problem, which means it's not a bad idea just to do the problem every time. And don't touch your calculator. I'm taking it. Order of operations. Start on the inside. That's what you did yesterday. What is arc sine of 1, or what's that asking you? Yeah, so where does sine equal 1? Pi halves, right? Sine is y. So could I say that's the same as saying what's the sine of pi halves? Right? Like you work with the inside and work your way out. And what is the sine of pi halves? Which means, does that property we just the property that we just wrote out works on this one? That you could just say sine and arc sine cancel each other out, and you just get 1 back. If you didn't know that, was it that hard to actually work that out? Not if you know your trig stuff. Right? So my advice is maybe just work it out. It's good practice. Because if you're not sure if it's going to happen. But sometimes that property doesn't work, like on this problem. And notice it could be the inverse could be on the inside, or the inverse could be on the outside. Just like we wrote it out. That's why you wrote it out 2 ways, because it doesn't matter which way it is. The mistake that people make is they try to latch onto those properties and think that you can always just cancel it out. 7 pi halves is not in my interval, which means I don't think I can just cancel these out. Oh look, you came back for pre-cal. Yeah. So step 1, where's 7 pi halves? Y-axis up here, y-axis down here. How could we tell? That's bigger than 2 pi, right? Could I subtract 2 pi from that to see where I'm at? Minus 2 pi. That would be like minus 4 pi over 2. So what's 7 pi minus 4 pi? So 7 pi halves is the same as 3 pi halves, right? Remember, if it's bigger than 2 pi or smaller than 2 pi, you always can add or subtract 2 pi. Which means I'm at 3 pi halves. So now do the inside part. What is the cosine of 3 pi halves? 0. Cosine is x. If I'm on the y-axis, doesn't really matter where I'm at on the y-axis, right? If I'm on the y-axis, of 0. Now, what is the arc cosine of 0? Or what angle has a cosine of 0? Arc sine of 0 is 0. Right? Pi halves, right? It's like saying the cosine of what equals 0 between 0 and pi. Right? That's what you got to be going on in your head. So it's not 3 pi halves. It's not 7 pi halves. It has to be between 0 and pi. And the only angle between 0 and pi has a cosine of 0 is pi halves. So you see how that property that we wrote out is misleading? On your test, there will be a question like this, and the majority of people will cross those out and just say the answer is 7 pi halves instead of actually working it out. Work it out, because you can just work it out and get the answer. But this is why we're having that quiz tomorrow, because you have to know these values. You have to be able to tell me where does cosine equal 0, or what is the sine of pi halves. And I still have lots of blank looks on faces out here when I ask what is the sine of pi halves. Sometimes the property is not going to help you anyway. Like, what if I gave you this problem? Find the sine of the inverse cosine of the square root of 3 over 2. The property could only work if it's sine and arc sine, or cosine and arc cosine. If they have a sine and an arc cosine together, the property is never going to work because they're never going to cancel each other out. But it's the same process. Start with the inside, do the inside, and then take the outside function, whatever's left. So again, this is what we did yesterday. You've got to know that this is asking you what angle has a cosine of the square root of 3 over 2 on that specified interval from 0 to pi. Cosine from 0 to pi, you have to be over here in quadrant 1. It's got to be pi 6 or pi thirds, right? That's the only one that has square root of 3 over 2 in it. And x is pi 6. Right? Like, I don't know what else to do at this point if you don't know those values. Which means I can replace this with pi 6. Because our cosine we learned yesterday has to be between 0 and pi. 5 pi 6 is negative square root 3 over 2, right? Over here, isn't cosine negative over here? Yeah. And so if it was negative square root 3 over 2, you're right, the answer would be 5 pi 6. Okay? And now I want to know what is the sine of pi 6. What's the sine of pi 6? 1/2. Which means the answer to that is just 1/2. Which is why this would show up on a no calculator part of the test. Because obviously you could just type stuff in your calculator, but that's not really going to get you very far on a no calculator part. Or the quiz smart, which is no calculator. So try this one. Don't yell it out. Inside first, then work your way to the outside. See if you can get an answer. Cosine of pi thirds, that's up here. That's 1/2, right? That's 1/2 square root of 3 over 2. And then now arc sine's on the outside. So now this is what we did yesterday. What angle has a sine of 1/2? And notice, depending on what is on the outside part of this problem, determines whether you get like a number answer, right? When sine or cosine or tangent's on the outside, you're going to get like 1/2 as an answer. But when inverse trig is on the outside, your answer is going to be an angle, because it just depends on what's on the outside when you're doing this. And so that would be the answer to that. So again, more practice with knowing your values, but also more stuff that you have to know your values. Questions about that? I think I got one more on here. Angel, you look confused. On which part? On where I get 1/2?
Well, I get that. I just the arc was throwing me off because like I want to think of it as inverse, but then you said like in this example you just use angle, so.
But that's what we did yesterday, right? Like in your head you should be saying this is like saying the sine of what equals 1/2. That's when you see arc sine, that's what you should be thinking. So like what angle has a sine of 1/2? So go to your unit circle. And then you're like, oh, at pi 6, the sine is 1/2. So your answer, all of your answers yesterday, like 1 through 12, should have all been angles, right? So that's why the answer is an angle. Okay? Let's do one more. Oh, just kidding. Not one more. Let's do that. So now I can give Colton his calculator back, because the calculator's not going to help you much on this one. Because now I'm just going to put X in. For you. It's the same idea, except for now I've taken the numbers out of it, which means it really kind of tests to see if you understand what this is saying. And notice I drew a little triangle because we're going to have to go back to our triangles to solve this. And notice it just says find an algebraic expression. We're not going to get an answer like pi 6 or 1/2 or square root 3 over 2. We're not going to get an answer to a problem like this because we don't know what x is. We just want an expression that we can change from trig stuff to just something with x's in it. That's what we want to change to. So again, work with the inside first. Kind of forget about the tangent for a minute. This is what we did yesterday. Do you agree that in your head, when you see arc sine of x, you should be thinking that's like saying the sine of some angle. Is it okay if I say the sine of some angle theta equals x? That's what this means. That's the definition of arc sine. And whatever theta is, that's what we replaced there. Like on the last one, I'm going to just go back for 1 second just to show you. Like on this one, whatever was true for that, that's what angle we plugged in there. So like if theta was pi 6, then we replace that with pi 6. I don't know what theta is, but it's going to be something, right? That's where the triangle comes into play. Draw yourself a little triangle. Label one of those angles as theta. Doesn't matter which one, as long as it's not the right one. The acute angles. If I know sine of theta equals x, could I label that triangle using what I know about sine? What's the ratio for sine again? It's been a while since we did triangle stuff, but sine is... So if this is theta, and I know that sine of theta equals x, could I say that this is x and this is 1? Could I solve for this side of the triangle in terms of x? I don't know what x is, but I could. I could do Pythagorean theorem, and I could say that x squared plus this side. I don't know what you want to call this side. I always call it b. Like I think like a squared plus b squared equals 1 squared. You can call it whatever you want as long as you don't call it x. Because if you call this x when this is already x, we're going to have big, big problems. So call it happy face. I don't care. Or sad face, since you hate math class. Or sleepy face, Trevor. He didn't even hear me. So I subtract x squared over, I take the square root, and I get that that is the square root of 1 minus x squared. Do not tell me that that's 1 minus x. You cannot separate addition and subtraction under a square root. So even though 1 is a perfect square, even though x squared is a perfect square, you have to leave it under the square root as 1 minus x squared. So why would I do that? Because I have to find the tangent of this problem. And that's where this triangle comes into play here. So this is going to equal whatever theta is. Do you agree with me on that? So could I say that this is the same as just saying tangent of theta? Can you tell me what the tangent of theta is using the triangle? Tangent is, what's the ratio again? X over the square root of 1 minus x squared. We just took something that had trig in it, an x, and we got rid of all the trig stuff, and we can say that this statement is equivalent to this. And now here's where I try to make life easier for you. Normally I say we got to get rid of the square roots in the bottom, right? And we could. This isn't that bad to get the square roots out of it, but it's all x's, it's not numbers, so you don't have to rationalize your denominators unless you just really love rationalizing your denominator. You're welcome to. It's not that bad. Like it would be x times the square root of 1 minus x squared all over 1 minus x squared. Like that's what you get. But I don't know that that looks any better than this. So I'm just telling you that on your homework today, you can just leave it like that.
So if like we would come up that in our test or quiz, just like that, we only do this. There's nothing like no other ways.
There's no other way to do it because we don't know what x is. You have to draw a picture and do it. We're going to do another one so you can kind of see what you do. But every time, draw a picture for your triangle for whatever the inside is. Because it's always going to be like arc sine or arc cosine or arc tangent. Draw a picture, solve for the third side, and then just do the outside function. Like it always gives you an equivalent statement. So let's do one more because I kind of did this one for you. Like same idea, what if I said find the cosine of inverse sine of 2x? There's no trick to it. There's no calculator stuff that can help you. Which means I'll probably put this on a calculator part of the test just because the calculator I don't think any of our calculators, you can type x in and it gives you the answer in terms of x. You can try, but I don't think it's going to work. So I always rewrite it, but you don't have to. But like I always see this and I always say, well, that's the same as saying the sine of theta equals 2x over 1, because those are my two sides of my triangle. So draw a triangle, label one side as theta, not one side, one angle is theta. Yeah, and I mean, unless technically they could give you a fraction here, right? They could, but most of the time they don't. So it's usually fine. And I tend to do the Pythagorean theorem in my head. You don't have to, but we'll see what we think on this one. It doesn't matter which angle you call theta. I tend to always stick to the bottom corner, but if you call this theta, as long as you label the opposite side correctly, it doesn't, like, we're going to get the same answer. Right? Opposite over hypotenuse. If you know the hypotenuse and you know one side, when you do Pythagorean theorem, every time you're going to have to take the square root of this squared minus this squared. Follow me on that? And you can write it all out. 1 squared equals 2x squared plus b squared. But every time, if you know the hypotenuse, you're going to subtract this over, you're going to take the square root. After you do a few of these, you'll probably get pretty good at Pythagorean theorem. I tend to just write it, and I always just do that in my head. I say, I'm going to take the square root of 1 squared minus, be careful here, we're going to square that, right? So that's not 2x squared. That's 4x squared. Probably the biggest mistake people make on this is they write that as 2x squared. Again, people really want to separate that because 4 is a perfect square, x squared is a perfect square, 1 is a perfect square. But you can't. You have to leave it with a radical. C squared equals a squared plus b squared. So 1 squared equals 2x squared plus b squared. So 1 equals 4x squared plus b squared. So 1 minus 4x squared equals b squared. Right? In second hour, someone said, couldn't you take 4x squared minus 1? No, because you have to subtract this over with the hypotenuse, right? The hypotenuse is always bigger. So it's really important that you have 1 minus 4x squared, not 4x squared minus 1. So if you need to do it out, work it out. If you get your triangle right, it's really easy from there, because now what are we going to do? If that's my triangle, what's this problem asking me to find? The cosine of that angle. So that's why we have to find the other side. So now your answer is, what is the cosine of that angle? Adjacent over hypotenuse, and since hypotenuse is 1, the answer to this is just the square root of 1 minus 4x squared because it's over 1. What's wrong, Angel? Do you get with the triangle part?
Yeah, I know. It's just the answer.
And
This
so,
is everyone, it's just that.
yeah, so this is always theta. So just like on the other problem we've been doing, you do the inside part first. The inside part's always going to be whatever theta is. So then we just do cosine. Cosine is adjacent over hypotenuse. Adjacent is square root of 1 minus 4x squared. Hypotenuse is 1. We don't leave our answers over 1. Yeah. Definitely going to be on your test, stuff like this. That's it. That's your homework today. It's not so bad, I don't think, but still no graphing, which is a step up, right?
Will you give us an example after this of the graph looking up the quiz?
I will not give you an example of the graph that's going to be on the quiz, but I will tell you there are two graphs. One of them has asymptotes and one of them does not have asymptotes, which means you need to know all of them. You need to know sine and cosine, remember how to find the period, and remember to find those 5 points, right? So like you need to remember find your period, then you take 0 to your period, take half of it again, and you should know your patterns at this point. Like go back and look at them, and I'm going to pass back that worksheet, and I'm going to pass back your homework quizzes, and if you've missed a graph on there, you definitely want to look at them and see what you've missed, but we should know that sign starts at 0, it goes up, back to 0, and it goes back down. And those should be your 5 points every time. There's 1 point, 2 points, 3 points, 4 points, 5 points. So if you find your period, you take half of it, you take half of it again, you should be getting that, right? Your amplitude is how high and low it goes. If it's a negative, it's flipped over. You have to know that cosine starts up at 1, it goes down to 0, down to wherever the amplitude is, back up to 0, back up to 1. Those are your 5 points. 1, 2, 3, 4, 5. Sine and cosine. No asymptotes. That's one of those. I mean, obviously it's not just going to be sine of x or cosine of x, but.
So like once you like find your period, like do your x's like divide that by half and whatnot. Whenever you find y, you just plug in the equation for x.
Yes, but you shouldn't even need to plug in your. I mean, that's fine, but like. I don't plug in for my equation ever because I know no matter what.
You just have to find the first number and then you fill in like 0.
Yeah, like on sine, no matter what my 5 points are, sine always starts at 0, the middle number is always 0, the last number is always 0. In between are your amplitudes, right? And if it's not a reflection, this is going to be your amplitude, this is going to be your negative amplitude. Normally 1 and negative 1, every time. If you don't know that, yes, plug in all your x values and you'll get those. But you shouldn't be having to do that every time because you should know what sine looks like. What I'm looking for is, are you labeling these values correctly? Because that's, I think, the hard part of the thing. But you're right. If you find all these, whatever they happen to be, plug them in, you should get those values.
So whenever that first verse is like, you should get 0 or could that change?
Always. I mean, the only change could be if I gave you a vertical shift, which I don't think I'm going to do that on your quiz tomorrow. But remember, I'm not making you graph any phase shifts. Every sine graph we have graphed has started at 0. And cosine, every cosine graph, whatever those 5 points are, cosine always starts, well, I'm going to just put 1 here, but your amplitude can change that. 1, 0, negative 1, 0, back to 1. And whatever your amplitude is, changes that, because that could change to like 4 and negative 4 or whatever. But for me, I don't plug any of those x values in, because I know that's what's going to happen every time, right? But you're right, whatever those happen to be, plug them in, and make sure you get those. If you pick the right x values, you should have no weird numbers over here on sine and
So
cosine.
it won't be like decimal or
You shouldn't, if you pick the right numbers.
so like sine and cosine are basically just opposite.
They are, because really they're just a phase shift away from being the same graph. There also is one that has an asymptote, which I'm not telling you which one it is. It could be tangent, it could be cotangent, it could be secant, it could be cosecant. You have to know the rules for your asymptotes. So that's the one thing I would say you need to study tonight, is you have to know tangent and secant. Their asymptotes are setting the Vx minus C equal to what? Pi halves and negative pi halves. In cotangent and cosecant, you set the asymptotes equal to 0 and pi, and that's the number one thing. Find your asymptotes, and then you set them all equally apart. And if it's tangent or cotangent, it's just those S graphs. If it's secant or cosecant, it's just the U's in between the asymptotes. If you can find your asymptotes on those, and you know the general shape, then you should be okay. So I'm going to pass back your homework quizzes and your worksheets, so then you can let me know if you have questions on that. That's what I would say you should study. If you're wanting some problems to practice, go back and do problems from our homework or from our notes that you have the answers to, right? Like don't pick something that you don't have the answer to. Pick an odd problem or pick something in our notes that we've graphed together, and then on a separate sheet of paper, write it out, like tangent of x over 2, because I think we did that in our notes. And then see if you can get the right graph and check with your notes. Like that's how you practice math. Don't just do random problems that you don't know the answer to. If you're trying to study, pick problems that you know the answer to that you can practice and check to see. So like that's how I used to study when I was in college math. Like I would redo a problem from my notes, I'd write it on a separate sheet of paper, I'd work it all out, and then I'd look at my notes. And if I didn't get the same answer, then I could go back through my notes and be like, oh, I messed up here. And that's what I would suggest doing for your graph practice. Okay? Those are like the graph part is the part that really I think you should be worried about. If you don't know your trig functions, your unit circle, then that's another issue.